Okay, so today we're talking about evaluating and graphing exponential equations. So super, super important that, again, we're taking good notes. We're making sure we're writing these examples down because you're definitely going to need them when you go over the homework tonight. Okay, so what we're talking about today is evaluating a function, essentially, and we've done evaluating functions before. So essentially what we're going to be doing today, thank you, is just evaluating a different kind of function. So we're used to evaluating linear functions, right? Like 3x plus 5. Same thing we're doing today, except we're going to be plugging a number into the exponent instead of plugging a number in to the multiplication, like y equals mx plus b, something like that. Okay, so just as a comparison, let's evaluate a linear function and an exponential function side by side so we can see the difference. Okay, so we just started with the notes. You didn't miss anything. Okay, so looking at the linear function, this says 3 is multiplied by x, and then we're adding 5 to that. We're going to be putting 10 in place of x. So we keep the 3. Instead of x, I'm going to replace that with 10, and we're multiplying. So I use the parentheses, and then we're going to add 5. 3 times 10 is 30. We add that 5 in, and so our final answer is 35. Okay, super easy. Now, with the next function, the exponential function, we're replacing x with 2, but instead of multiplying, x is now our exponent. That's our variable. So we keep the 4, and then instead of x, I put 2. So now that's 4 squared. And then we're going to add 5 to that. So remember, order of operations, I'm going to do my exponent part first. What is 4 squared? 4 times 4, which gives us 16. And then we're going to add 5 to that. And so our final answer is 21. Okay, so nothing really more complicated than evaluating, which means we take the variable out and we plug a number in. Really, really straightforward. It's just that today we're plugging in the number into the exponent instead of plugging in like we're multiplying. Okay, so what we're going to do today is we're going to go through a series of examples. So I have a couple examples for you. I'm going to walk you through all the different kinds of things that might be on your homework tonight. So please make sure you're taking some good notes or you're paying really close attention because, again, this stuff will show up tonight on your homework. Okay, let's jump in. Example number 1, super straightforward. So here we have f of x equals 6 to the x power plus 3. And instead of x, we're plugging in the number 3. Okay, so we are going to keep the 6. Instead of x, that changes into 3. So now that's 6 cubed plus 3. Now, 6 cubed is one of those numbers that we don't work with often, so you might not know that value off the top of your head. So, of course, you can use a calculator. Super easy. In the calculator, you can either type in 6 times 6 times 6, or you could just type in 6 cubed, especially really easy if you're using the calculator on Google. You just use that up arrow or the caret, right, right above 6, and that will help you find what 6 cubed is. Anyone know it off the top of their head? There you go, 216. So 6 times 6 is 36, times 6 is 216. And then from that, we're going to be adding 3. And so our final answer is 219. Super straightforward. So again, we just plug in the number for our exponent, and then we add the 3 in, following PEMDAS, of course. So exponents first, and then adding and subtracting at the end there.
I think sometimes see the pattern in it.
Hopefully. Okay, let's try another one. Okay, if you need more time to write stuff down, please let me know. Okay, here we have a big reminder. Anything with a 0 exponent equals 1. Now, big caveat to that. It doesn't mean the answer is automatically 1. Okay, it just means if you have a base and the exponent is 0, then that turns into 1. The whole answer doesn't turn into 1. So for example, here we have 2 to the x power plus 7. We're replacing x with 0. So that becomes 2 to the 0 power plus 7. Okay. So what is 2 to the 0 power?
2 times
1. Anything to the 0 power is 1. Okay, so that becomes 1. But does the 0 exponent affect the 7? No. So we keep plus 7. And so my final answer is 8. Very good. Awesome. Now, this is super important. If there is a negative sign, you have to be really careful. So for example, if it was negative 2 to the 0, I want you to think of this like order of operations. Okay, so we would do the exponent part first, and the 2 to the 0 exponent only affects the base of 2. Okay, so 2 to the 0 would be 1, then that gets multiplied by the negative sign, so this would be -1. Well, we're just talking about the -2 part right now. But yeah, if you were going to add 7, you would add 7 to that. Okay, so that's very important. If there's a negative sign in front and there's no parentheses, then you do the 2 to the 0 first. That makes it 1. And then the negative makes it -1. Got that locked in? Okay, let's try another one. Next problem, again, we have a big reminder to use PEMDAS. So remember, we have parentheses and exponents first, then multiplying and dividing, then adding and subtracting. Now in this problem, we're going to take the x out, we're replacing that with 2. So I'm going to keep the 4. And then in parentheses, I now have 5 squared, because I take the x out, put a 2 there. And then I'm taking away 20 from that. Okay. Now, what should I do first? 5 squared or 4 times 5? Why should I do 5 squared first? Good, it's in the parentheses and it has an exponent. So we're going to do this part first. So I keep the 4. 5 squared, that's 5 times 5. That gives me 25. And then I bring down the -20. Okay. Exactly. So now we're going to multiply 4 by 25, and that gives me 100. And I'm going to subtract 20 from that. And my final answer is 80. So remember, PEMDAS, in order, we did the parentheses and the exponents first. Then we did the multiplication. And then we did the subtraction. Okay. So whenever you're thinking order of operations, make sure you're following PEMDAS. Okay. We did parentheses and exponents. Then we multiplied by the 4. Then we subtracted that 20. And we get our final answer of 80. Okay. Any questions so far on the problems that we've gone over? I just want to make sure I check in and see if anyone wants me to go over something again. What's up?
What is the exponent?
Is a negative? That's going to be one of our next problems. We'll get there. Okay. Any questions on these? Okay, perfect lead in. Negative exponents. Remember that negative exponents do not mean that the answer is negative. It means that we have to turn the answer into a fraction. Okay, so here we're replacing x with -4. We have 3, which is our base, and now the exponent is -4. So remember, these problems are not too difficult.
Yeah, it's no times table.
Okay, so essentially, we're asking ourselves, what is the positive version? So what is 3 to the 4th?
It's
Not 12, that's 3 times 4. 3 to the 4th means 3 times 3 times 3 times 3. So what is that? Not 6. 3 times 3 is 9. 27. Okay, remember, not 64, bigger than that. 81, okay? So because the positive version, 3 to the 4th is 81, we just have to turn that into a fraction. So we do 1 over 81. 1 over 81. That is our answer. Okay. So with negative exponents, it's honestly super simple.
Yeah.
You think,
You guys have to think about what the answer would be if it didn't have a negative.
Uh-huh.
And put it in a fraction.
Exactly.
And what about it?
So 1 over whatever the answer would be if it were positive. Exactly. Okay. That makes sense for the negative exponents. Okay. So it doesn't matter what the base is. You consider what would the base be to the positive version and then 1 over that number.
That actually does make a lot of sense.
Perfect. Okay, let's keep going. Now we have a fraction. Now, a lot of students look at this, they see a fraction and they think, oh no, I don't know how to work with fractions, but really not that bad. Okay, so we're going to keep the 1/2 in parentheses. And then instead of x, I'm replacing that with the 3. And now we got to think back to our exponent rules. So this 3 on the outside is going to become the exponent on both of the numbers on the inside. So on the top, you have 1 cubed, and on the bottom, you have 2 cubed. So pretty straightforward. Now, remember, 1 cubed means 1 times 1 times 1, which is what? Just 1, perfect.
Yeah, it's just 1 because when you multiply something by 1, it
Stays the same.
same number.
Okay. Now, what's 2 cubed? That's 2 times 2
It's
times 2.
2 times 2 times 2.
2 times 2 times 2, 8. So 1/8. That is our answer. Okay. So remember, when we have an exponent on the outside, you apply that exponent to everything inside the parentheses. We learned that in our last chapter on exponent rules. Okay. So that's why the 1 becomes 1 cubed and the 2 becomes 2 cubed. So very straightforward. Even though it's a fraction, doesn't change how we do the problem. You still take the outside exponent and apply that to the inside of the parentheses. Okay. We got a couple more. Okay, a couple more. We're almost done with our lecture. So next problem. Here we have a base of 2, but then we have more things going on with the exponent. So this, we got to be very careful here, okay? So I'm going to keep the 2. Instead of x, I'm going to replace that with 2. But I still need to write the +3 part. Okay, that's our exponent. And then -7, that comes next. You do. So we're going to keep the 2. And then what's 2 plus 3? So now this is our base to our exponent, 2 to the 5th. And then whatever that is, we're going to -7 from that. Okay. Now, does anyone know what 2 to the 5th is?
16.
Not 16. You got to go one more.
Oh,
32. Very good. And from that, we're going to take away 7. So 32, take away 7, gives us a final answer of 25. Okay. So you were close. You did 2 to the 4th. You just need to go one more multiplication by 2.
I think
You got it. So on a problem like this, very straightforward, we are going to keep the base, and then we have to do some math to get the exponent correct. Okay, not too difficult. We just got to make sure we're paying attention to that. Okay, we have one more example, and then we're done with our lecture. Okay, everyone good to move on? Okay, last problem. Same thing here. We are going to replace x with this value right here, but then we have to clean up the exponent a little bit. Okay, so we're going to keep the 3. We're going to keep the negative sign, We're going to keep the parentheses. Instead of x, what number do I plug in? 5. We're going to keep the -2 and then close that parentheses up. Okay, now let's simplify this a little bit. Keep the base of 3, keep the negative sign. What is 5 take away 2?
3.
Exactly. And now we have 3 to the -3rd, which we know how to work with.
Yeah, we just deal with it like if it was positive, but
Exactly.
it's a fraction.
So we're going to make it a fraction. So we know the answer is going to be 1 over something. So we have to go to the side. We have to ask ourselves, what is the positive version? What is 3 to the 3rd power?
27.
Very good. 27. Remember, that's 3 times 3 times 3. So the final answer is going to be 1 over that. So 1 over 27. Very, very good. And that's it.